Welcome to Reimagine Mobility Podcast. I'm here with Meghan Cottam. She is a software developer for AVL Mobility Technologies. Thanks for joining me, Meghan.
Yeah, thanks for having me.
It's your first podcast, I just found out. So
it is,
we're going to have a blast here over the next 20, 25 minutes. And maybe to start out with, you started with us in the ADAS space, software development for ADAS space, tremendously growing field. Why ADAS and why software? Why did you ever choose software engineering? Why did you ever choose ADAS as an area that interests you? Maybe give us a perspective there.
Yeah, so I actually started in test and development for ADAS. So
Okay.
I helped with validating, the production vehicles or before production and making sure the software and calibration was good for production, and also helped develop and define the operating parameters for upcoming ADAS features and stuff like that. So most people don't that buy new cars don't really know how the ADAS systems work or haven't had experience with them before. So it's really important to design them and calibrate them so they're intuitive, robust, smooth, things that give the drivers confidence and want them to leave the features on and not disengage them because they're too maybe too annoying or too aggressive. So I worked doing that and defining the expectations for those features, and would work with controls engineers and design engineers on how to meet those expectations. And so working in that a couple of years, I wanted to pivot and kind of get on the other side of that.
To the development side.
To the controls development. So that's kind of what got me here. I had a lot of experience behind the wheel with ADAS and had an expectation of how it would behave. So I had that background and came here to start designing controls and working on that.
So what you described before about features, people are not comfortable, they don't know it, they may not perform perfect or at least to somebody's personal expectations, so they turn it off. I mean, you described my wife. That's exactly what she does. I don't like the adaptive cruise. I don't like this. I don't like that. Just turn it off. And I turn everything on I can, right. And hands off. I want to see how it works at times, and then put the hands back on. Cover my eyes if I have a driver monitoring system to see how fast does it pick. And he's like, you got to stop this. You got to do this. So maybe go back to that a little bit for a moment. How far do you think we have to get still that really more people, even again, somebody like my wife who's driving usually more modern vehicles that has some of those features in it, but still always seems to turn them off. How much further do we have to go as an industry to really get to a point where it's not a question anymore about turning it off? It's a question about why not turn it on, right? You know what I'm saying?
Yeah.
Where do you see, with your background now, both again in helping define and make people more comfortable with these things, and now also on the software development side, you have somewhat of a unique perspective, in my opinion, from both ends. Where do you think we still have to go, or how far do we still have to go to get that confidence? And maybe it's just a matter of, it's just time. It's just people need to get used to it. It's not a matter of the technology getting better or more reliable, or instead of 99%, it works 99% of the time. It has to work 99.99999%. But share a little bit your perspective, how you see it personally.
Yeah, I think one of the biggest things that I've seen is people need to understand how it works. And so I think the big gap there is it might work well or under the right conditions, or it's meeting the design parameters it was meant to, but people don't know what to expect from it. They don't know the conditions in which, for example, AEB should be working. I would read customer feedback sometimes, and they'd say, I try to run into a wall and it didn't stop.
Are you serious?
Yeah, and I had to hit the brakes, and that's not what it was designed for. So we're looking for classified objects for vehicles or pedestrians or cyclists. It's not going to stop for a wall. It's not going to, stop for a random box, which it's just, you need a lot of data to be able to do that. So I think one day we'll get there. And maybe that's when that's where the technology needs to be for people to trust it or want it. But I think the biggest gap right now is you get in a car and you turn the button on and you don't intuitively know.
You don't feel a difference necessarily, right? When you turn the button on, right?
Yeah. So if you have adaptive cruise control on, you don't know what are the limitations of this feature. At least someone who hasn't been using it, and at least in my experience, most drivers don't actually open the owner's manual to get the idea of what the feature is capable of. So I think they either expect it to do a lot more than it can do based on the sensor limitation. Or they just don't trust it because they don't know what it's capable of. So I think there's just a big disconnect in teaching drivers or newer customers on how to use their vehicles. And I think a lot of that has to do with like the user interface as well. You just have a new icon, and sometimes we don't know what it means.
Know what that means? Yeah. Interesting. I mean, you brought up a point about when you shared about the feedback of the customer. I tried to drive it into a wall. I heard a story once, I don't know if that's true or not, but I heard a story when cruise control first came out, that a lady was in a minivan driving, put the cruise control on, and thought that allows her now to get back and take care of a kid that was crying in the back. And I guess that happened on a highway.
Oh, no.
Now, luckily, then nothing happened, but she found out later, was later told that that's not what this is all about. This is well before we've talked anything about lane keep or AEB or adaptive cruise or any of the stuff that's out now, right? So it's interesting. So from a software perspective, does the way we develop software in the industry, has that changed because of what you just explained? The perception is of people of ADAS features or how they use it? Or have we really we continue to push forward in the journey to get to level 3, level 4, and then ultimately level 5? Or have we made some adjustments as it relates to not necessarily the coding language that we use, but features and how we're maybe implementing it? Again, you mentioned the HMI, right? Are we more conscientious about that than maybe we were 2 years ago, where we say, well, we put an icon there, who cares? It's about the AEB function, not about making the driver aware of it. Has software changed in how we develop features because of that, or not?
Like the core software, I would say, has been probably the same, but definitely like the user side, that type of software and design has changed. You see more feedback from the vehicle. I think before it was kind of just an add-on, and now, the cockpit is designed with this idea that the vehicle will give you feedback. And in terms of the actual controls, I think, making the responses more intuitive, make the driver feel more comfortable with how the vehicle's performing. And I think you'll see a lot more of that with features that include machine learning or things where they can actually learn how the driver wants to drive the vehicle.
Yep.
And that's where you'll see the software really, the core software change, and in terms of how aggressive should I accelerate, how much distance do you like to keep to the vehicle in front of you. And you can learn that through, just daily driving, and then when they press cruise control, it will be tailored to them, and they don't have to go through a screen with a lot of settings to tailor to them and then try them out. And so I think over time, yes, we will see it be more tailored and more intuitive for drivers going forward.
Would you say then with that answer you just given, I assume then that maybe 3-4 years ago, the HMI portion of ADAS was nowhere near as important as it is today. And it was more the function of, or the focus on more of accuracy of object detection, object avoidance, lane keep, all of those features for a level 2, 2+, now going into level 3. Would you say then HMI really has gained a tremendous level of higher appreciation now because of what we've learned over the years as it relates to adaptation?
Most definitely. I think you would have, a lot of, you can see it with the change of like the cluster design as well, from going from an analog to more digital, because you definitely have more freedom to give that feedback to the driver. I think in newer vehicles, I see more and more the ADAS screen keeps getting bigger and bigger and giving more feedback. And so I think that's like the biggest place you see it. And then you have other companies adding lights and the steering wheel or on the side, or
different interfaces, lights or voice or vibration or whatever it might be, right?
Yeah, exactly.
Interesting. So let's maybe pivot a little bit, because you also do software for electrification, BMS specifically.
Yes.
Tell me a little bit, is there a big difference for you as an engineer working on a BMS software versus working on an ADAS? And the reason I'm asking is BMS, let's say, I'm not going to argue what's more important, the ADAS or the BMS, but the BMS is certainly not as user-facing as we just talked about ADAS is. Does that make it more challenging for you? Does that make it more, I need to be, more careful when I do something that's customer-facing versus something that's not? Does it make a difference for you? Does it not make it? Does it make it more attractive? Share a little bit the differences when you look at between ADAS development and, let's say, BMS development.
Good question. So with, like you said, with BMS, it's definitely more behind the scenes software, and it's important for safety and longevity of the battery and powertrain. But I personally think ADAS software, there's a little bit more pressure there, because if you get it a little wrong, it's very obvious. It's everybody knows, and
a little wrong is very wrong.
Yeah.
You don't have that in BMS. I mean, if you calculate a certain SOX algorithm, that's...
It is. It's definitely important, of course.
Yeah.
I think you just, in terms of, well, I guess it could be more important, because then it's harder to find right away. But BMS is definitely challenging as well. And in terms of the actual software that goes in it, it's a lot more than I think people realize.
On a BMS, you mean? Yeah. Okay.
But it has been, I think, around or more defined. Whereas I think in ADAS, you kind of have a little bit more liberty in your strategies, and everybody does it a little differently. And there's like pros and cons to all those type of ways. Okay.
You kind of mentioned more pressure maybe, right? Is there more pressure because not only is it customer facing, but also you can cause a crash, whereas maybe with a BMS, let's say for a moment, the worst that could happen, or let's say what could happen is I run out of juice sooner than what the display told me because of a wrong calculation we did. But it's not necessarily a matter of life here potentially. On one side you could crash, on the other side you just stranded on the side of the road. As a software developer, do you think about these things when you write software, or is that you kind of have to, you think about it, but you have to put this aside, otherwise you get hesitant and you don't trust yourself? You know what I'm trying to say? Is there something like that? Because I always wondered, I've never done software for ADAS, it's not my area of expertise, but I always kind of felt like with some people that I work with, they're always like, well, this is a safety critical thing and I'm really concerned about this. I'd rather work on an infotainment system. If a button doesn't work, a soft button doesn't work, okay. But if this feature doesn't work, it potentially can cause a crash where somebody could get injured. Is this something you guys think about, or you think about when you write software?
I mean, you definitely want to write safe software.
Sure.
I wouldn't say that it's it's on my mind the whole time. There's so many so much tests you have to do, and a way to develop the software, a way to develop the feature, so you can develop it in the safest way possible. Even before you do the controls, you define the feature, you define the limitations, the accelerations, the max steering torques, and you define those in a way that's safe, or at least can be overridden by the driver, so the driver is always in control of the vehicle. And by doing that, I think the software, there's not as much question as to whether it's safe or not. Of course, you still have to do a lot of testing, do simulation, do it mill, sill, all the types of testing you can to make sure it's behaving within like that design, the design specifications.
Okay.
But yeah, I think the pressure really goes on designing the feature first. So that's fortunate for me now.
Yeah. So you bring up a very good point. There's a lot of obviously processes as an entire tool chain, from the definition all the way to the definition of an ADAS feature all the way to the testing and validation of one. Within that tool chain, what is to you the most valuable tool or methodology? Let's say, I don't know, I'm thinking about functional safety. I'm thinking about a sill tester, a hill tester, maybe a vehicle in the loop tester, lots of other things in between that software people are using. What to you are the most valuable tools that you use?
Good question. I would say, for me personally, I would say it's like model in the loop or sill testing, because you can think your software is doing really well and you design it, maybe it's passing on your small test, but once you model the car and run it through a simulation and you see it's actually not stopping for something that you didn't even think of before, you can really catch a lot of issues there and make sure your software is passing all the software requirements before it even goes into a vehicle. And then once you're in the vehicle, of course, that's very important to make sure it's working well with all the other features and dynamically. But you can get, I think, so much done in simulation nowadays that really cuts a lot of time from the development process.
And are you doing it in a consistent, almost like agile loop on sprints? So you write software for 3 weeks, then you test it for 2 weeks, or are you doing it concurrently with the development? You also run a model in the background, so to speak, or in parallel to you developing? Share a little bit on how you're doing it.
Yeah, so we usually do model updates and then test that like on a lower level and make sure the software we're implementing or changing is running the way we expect it to. And then using like the agile process, we'll do integrate everybody's software changes and do a simulation and to ensure that everybody's is functioning together appropriately, and then catch a lot of bugs or see your work actually working in a very short period of time. So it's very satisfying.
Okay. So cybersecurity has become a big part of automotive space. I would say, again, I think it was big. I would say 7-8 years ago, everybody talked about it. Then it felt like it kind of got, not away, but it went dormant. Now it's really back again and very, very important. Clearly, we know why, because everything gets connected. Everything is interconnected. The vehicle gets more automated, right? We go to a higher level of autonomy, level 2+, 3 now, pushing into 4 on a widespread deployment at least. So cybersecurity threats or cybersecurity is a bigger issue. How much do you, when you write software, have changed things or need to change things now from an approach or from a coding perspective with cybersecurity, with functional safety as well, ISO 26262, but with functional safety and cybersecurity now more on the forefront than it may have ever been in history?
I think in my experience, I've been doing controls for like a little under 2 years, so it's, I think, been on the forefront for like the whole time I've been doing controls. I think the way things are modeled now, you have functional safety, the AutoZAR method, and model-based systems approach, where I think cybersecurity isn't as much of an afterthought anymore. You kind of bake it into like the controls process. So on a model level, it can be implemented there. So it's not like it was before, I would say, more of an afterthought that you would go back and try to make it, a safer software. So I think that is where you'll see the biggest change. Is mainly in the controls process. It's kind of embedded in from the beginning.
Okay. So for you, it hasn't been much of a change because you're saying over the last 2 years that has always been from the get-go when you came from that. Okay, that's fair. And maybe last question for you. I usually ask people that when we specifically talk about technologies, would you go back into software engineering again if you could rethink when you graduated from high school, what am I going to do? Or would you say, no, now that what I know now, I would probably go into different areas? Or you say, yes, I would, but instead of going to work, I maybe get my, PhD or go into AI, or share a little bit like that for some of the people who are listening or watching that maybe try to decide what career path to take.
Yeah. I mean, I would do software.
You would do it again?
Especially in mobility. I think the experience you get in a new vehicle or in mobility in general is so tied to the quality of the software in that vehicle. So there's, I think, so much power in the software you design. You can have bad software that kind of ruins the whole experience. So I really enjoy software and controls and would definitely choose it again, because you just even in the future, I think we're going to see that more and more too. So I think with time, software is going to become even more important, and you really do have like the power to control that experience for people.
Yeah, I'm not going to ask if software is more important than hardware because I know the answer already. So very good. Thank you, Meghan, for your time.
Yeah, thank you so much for having me.
Very nice. Thanks for tuning in.
Thanks for listening to Reimagine Mobility Podcast. If you liked this episode, please subscribe and tell a friend.